Hello everyone. In this video, I'm going to explain how to solve the quadratic equations. Quadratic equations are of the form ax squared plus bx plus c equals to 0, where a cannot be 0. So quadratic equation has to have an x squared term. And in order to solve the quadratic equations, I will discuss the two methods. First method is solving it by factoring method, and second one is using the quadratic formula. I will discuss that soon, but before that, you need to know that quadratics have usually two solutions, and it can never have more than two solutions. So maximum a quadratic can have two solutions because you have the degree of the variable 2. Sometimes it might have only one solution, but it sometimes it might have no solution. So I'm going to show you all the three cases. How does this happen and when does this happen? So for example, the equations have two real roots. So whenever we talk about the root of a quadratic equation, so one thing we know that a quadratic has the graph of a parabola. So let's say we have this case where our graph is intersecting the x-axis at 2 points. So x-intercepts are the solutions of this equation. So for what x values, our quadratic expression becomes 0. So if this is the graph of y equals to ax squared plus bx plus c, and we have this graph intersecting at 2 points to the x-axis. So these are the two real solutions of your quadratic equation. And we also call the solutions and roots are the same thing. So it means the value of x when y is 0. And in this case, we see that our parabola is intersecting the x-axis at 2 points. We have two solutions. And one thing that you can just by looking at the expression, you don't need to always graph your parabola. You can only look at the expression. And if your b square minus 4ac, this value is greater than 0, then we have two solutions. So you can even figure this out algebraically that how many solutions you're gonna get. So look at the value of b square minus 4ac. If that is greater than 0, you're gonna get two solutions. Similarly, if we can have another case where our parabola is something like this. So in this case, the parabola is intersecting the x-axis only at 1 point. So in this case, our vertex is on x-axis, so that is our only solution. So vertex is the solution. So vertex on x-axis. So we have only one real root in this case. And this happens if our expression b square minus 4ac equals to 0. In that case, we have only one solution, or we also call it repeated root. And there is a third case when your parabola does not intersect, something like this. So this one does not intersect with the x-axis at all, and in this case we have no solution because parabola and x-axis do not intersect. If you want to look algebraically, this happens when b square minus 4ac less than 0. So we have discussed the three cases when parabola can have two real roots or one real root, or your quadratic have no real solutions. In order to solve a quadratic equation by factoring, the steps are you first put the quadratic equation in the standard form. So by standard form, I mean the form ax squared plus bx plus c equals to 0 in this form. And then you're going to factor your left hand side. So you're going to factor this guy, so you will get the two factors and you will get that product of two factors is 0. So if the product of two factors is 0, it means at least one of them should be 0. Or in other words, we know that if, so let's say if one factor is a, another factor is b. If a times b is 0, so either a is 0. So this is true if either you have a equals to 0 or you have b equals to 0, because only then you can get product equals to 0. And in the end you check your solution. This is an important step. You can always plug in the value of whatever number you get in the end, put that in the original equation, and if you get both sides 0 and 0. Let's do a few examples. So first we have solve the following equation for x, and we are using the factoring method. And previously we learned that whenever we factor a quadratic expression whose leading coefficient is 1, we look for the two magic numbers such that the product is c and the sum is b. So what is b and c in this case? So if you compare it with x squared plus bx plus c equals to 0, so in this case your b is 6 and your c is 5. So product should be 5, sum should be 6, and two such magic numbers are, so what are the magic numbers? So magic numbers will be 5 and 1. So once you find your numbers, you can rewrite this as two factors. So numbers are x plus 5 and x plus 1. So product of two factors is 0. So it means either x plus 5 equals to 0 or x plus 1 equals to 0. It means either x equals to negative 5 or x equals to negative 1. Thus, the solutions are x equals to negative 5 or x equals to negative 1. And you can always check your solutions whether they work or not. So in order to check, so our original expression is x squared plus 6x plus 5 equals to 0. And see, if I put negative 5 here, do I get 0 equals to 0? So negative 5 square plus 6 times negative 5 plus 5 equals to 0. Is that true? So we get 25 minus 30 plus 5. And of course, we get 0 equal to 0. So it means, yes, negative 5 works. Similarly, you can plug in negative 1 and see if it is still true. So if I put negative 1 square plus 6 times negative 1 plus 5, so I still get 1 minus 6 plus 5. So I still get 6 minus 6, which is 0. So it means, yes, both of these solutions work. Okay, let's try the next one. So we have 6x squared plus 4 equals to 11x. So remember the first step I said, you put it in the standard form. So first we're going to write this as 6x squared minus 11x plus 4 equals to 0. And we have to factorize it. The first rule of factoring is you look for the common factors if there are any. In this case, there are no common factors. And then the next thing that we're going to do is we're going to compare it with ax squared plus bx plus c. And in this case, we notice that A is 6, B is negative 11, and C is 4. And this is the case when our leading coefficient is not 1, our leading coefficient is 6. So in this case, we're going to look for two numbers such that the product is AC, which means 6 times 4 equals to 24, and the sum is B, which is negative 11. So think about the two numbers whose product is positive 24 and sum is negative 11. And the two numbers are 8 and 3. But no, it should be negative 11, so negative 8 and negative 3. Alright, so when we rewrite those numbers, so we're going to use those numbers and we're going to split this middle term. So I'm going to rewrite this as 6x squared. Instead of 11, negative 11x, I'm going to write negative 8x, negative 3x plus 4 equals to 0. So this implies, so now we're going to do grouping by 2. So from the first grouping, these two we have 2x common factor, so we get 3x minus 4. From the second, we get negative 1 out, so inside we have 3x minus 4 equals to 0. And now we have these two terms, and from both of them we have 3x minus 4 as a common factor out. And in the first term you are left with 2x. In the second term you are left with negative 1. So we got the product of these two factors is 0. It means either of them should be 0. Either 3x minus 4 is 0 or 2x minus 1 is 0. So 3x minus 4 is 0. It means x is 4 over 3. Similarly, 2x minus 1 is 0. It means 2x equals to 1 and x equals to half. And in this case, we got the two solutions. So our solutions are x equals to 4 over 3 or x equals to half. And again, if you have extra time, you can always verify this. Next, we discuss some special cases. So sometimes you can have the pure quadratic, which the pure quadratics are the quadratics which have no middle term. So they have no b term. So for example, if you have 3y squared minus 27 equals to 0, in this case, there are two ways you can approach this problem. The first way is you might do from here, you get 3y squared equals to 27, y squared equals to 27 divided by 3, and y squared equals to 9. And then you take the square root on both sides and you say that y is plus minus 3. So that's one way. But the better way is if you are doing the factoring. So you can start with 3y squared minus 27 equals to 0 and you can factorize it. So first step is take the common factors out. So you get 3 times y squared minus 9 equals to 0. And then the difference of perfect squares, because 9 can be written as 3 squared. So we can use that formula. So we get the two factors y plus 3 and y minus 3. So now the product of these three factors is 0. So 3 is non-zero. This cannot be 0. So either y plus 3 is 0 or y minus 3 is 0. So in this case, either y plus 3 is 0 or y minus 3 equals to 0. So it means either y equals to negative 3 or y equals to positive 3. So this is our solution. Next one. So in this one, we have 3m squared plus 48 equal to 0. And if I try to factorize this, First, I'm going to take the common factors out. So 3 is the common factor. Inside, we are left with m square plus 16. So product of two factors is 0. So 3 cannot be 0, but it means m square plus 16 should be 0. And from here, we get m square equals to negative 16. So square of something is negative. This is a contradiction, so this is not possible. So it means in this case, we do not have any real solution. So no real solution in this case. So this will be the case when parabola does not intersect with the x-axis. Okay. Next, we discuss the case when we have incomplete quadratic. We do not have a c term. So we only have something of the form ax squared plus bx equals to 0. So no c term. X, and you might say, hey, let's divide by 2x on both sides. And then when you do this, you're gonna cancel your 2's, cancel your x, and you write x equals to 2. But the problem with this is when you do this, you are making the assumption that x is non-zero and you lose a solution in this case. So this is not the best way to do the problem. The better method is you start with 2x squared equals to 4x, and you write this as 2x squared minus 4x equals to 0. You try to factorize it. So 2x is a common factor and we get x minus 2 equals to 0. So product of two factors is 0. So either x is 0 or x minus 2 is 0. So either x is 0 or x is 2. So in this case, you got your two solutions. The solutions are x equals to 0 or x equals to 2. So this is the correct way to do this problem. And if we do with factoring, we do not lose a solution. And we do not make the assumption that x is non-zero. Okay, so this was our method of solving the quadratic equation using factoring. So next I'm going to discuss how to solve the quadratic equations using the quadratic formula. So we know that the common form of a quadratic expression is ax squared plus bx plus c equals to 0. So we can figure out the values of a, b, c. Then the solution is found by using this formula: x equals to negative b plus minus square root of b squared minus 4ac over 2a. And if you remember this expression under the square root b squared minus 4ac, this is also called discrimination. And this one we discussed that if this one is positive, we get two real roots. The method to use this formula is you put the equation in the standard form. If it can be factor, you solve by factoring. Otherwise, solve using quadratic formula. And quadratic formula always works. So quadratic formula always works. So sometimes you might not be able to factor something, but you can always use a quadratic formula. And in the end, you can verify your solution. Let's say we have the equation 4x squared minus x minus 6 equals to 0, and we want to solve it using the quadratic formula. First step is you compare it with the standard form ax squared plus bx plus c equals to 0. So in this case, our a is 4, our b is negative 1, our c is negative 6. So once you have the three coefficients, Then we're going to use the formula that x is negative b plus minus square root of b square minus 4ac over 2a. And let's plug in the values. Plus minus b square minus 4ac whole thing divided by 2 times coefficient of x square, which is 4. So this is the important step. So make sure whenever you do this kind of questions in a test, you show this step to show you're working. Show this on a test. Okay, 1 plus minus. So square root of 1 and then 4 times 6 plus 96 divided by 8. And then you can use your calculator, because one time you're going to get a solution. So x1 is 1 plus square root of 97 over 8. Another time you're going to use the subtraction and you're going to get the two answers. So either x is 1.356 or x is negative 1.106. So these will be the two solutions of the given quadratic equation. So just a recap, in order to use the quadratic formula, you look for the value of ABC and you plug in the value in the formula. And you can always use your sharp calculator if you have one to verify your solution of quadratic equations. So if you have the calculator, so I'm telling about Sharp EL520. That's the model I have. So you can check solutions. And you can always put your calculator in the quadratic equation mode. So you press on mode and then you choose number 2 for the equation mode, and then again you choose number 2 for the quadratic mode. And then it will ask you to plug in the values of a, b, c. If you press enter, keep pressing enter, it will give you the two values x1 and x2 in the end. I hope that makes sense. In the next video, I'll do some word problems around quadratic, the application problems. So make sure you do watch that video as well. Bye for now.